Alright, so when we were talking about system requirements, we're talking about some characteristics of good requirements. And there we talk about, you have to check out if the requirement is necessary. If it's verifiable, can I test it? Is it attainable? Is it a realistic, technically feasible requirement? Or is it clear? So if you go look at the textbook, they give you a nice kind of layout there of some characteristics of good requirements. It's a little bit more detailed. Of course, so if we run through this real quick, you want to use concise and complete sentences with correct grammar and spelling, of course. Use shall for each requirement, especially at the kind of the high level requirements. Make sure to use an active voice. Make sure to emphasize the important items. Maybe by adding a graph, a picture, making use of white space, making use of boldface, or like an itemized list. You also make sure that if you have terms that you use that may not necessarily be directly clear, that you have a glossary in which you define those. Of course, make sure that you don't use ambiguous terms to the extent practicable, modular, minimum, maximize, achievable. These are really not very clear what's meant by those. You need to be very clear. Somebody needs to be taking these high-level requirements and turning them into low-level requirements without having to need too much external information. Okay, so write these requirements at the appropriate level of granularity. Make sure that it's at the granularity that it can be tested by just 1 or 2 tests. Don't go into too much detail. Don't make sure that you have 30 or 40 tests that you need for it. And minimize or avoid actually words such as like unless and except. Don't use slashes. They actually are confusing, more or less. They give you ambiguity. Is it and or is it or? What is it? So don't use that. Of course, make sure to not really make too much use of it or they. It can often refer back to multiple nouns in an earlier part of the sentence that may be as a result there may be some ambiguity in your requirements. So you don't want to have that. So it's better just to repeat the noun. So avoid ie and eg, because a lot of people have a different interpretation. Not everybody kind of realizes that ie means that is. They think ie is the same as for example. So include rationale and background for requirements in notes and comments if it's needed. This time it's much better if you read the documents to get an idea for what the people were thinking. So make sure to avoid negative requirements. They're really difficult to verify. So don't do this. You shall not do this. It's really hard to verify that. And then build in robustness in your requirements by checking if the software would respond to abnormal inputs. And we'll talk about this in the verification modules where we talk about normal range versus off normal range testing. So avoid words that sound alike or similar, and if you use words that ending in ly, like reasonably, quickly, significantly, occasionally, they actually are typically a little ambiguous, so you may want to avoid those as well. And of course, one thing I forgot is to ensure that the requirements fully define the functionality. And you can do this by looking for omissions, things that you didn't specify that should be there. And this is something that you need to do, of course, as a requirements developer, and then in the verification process, this is something that you have to kind of bring out if you and a group of people maybe review these requirements. So what I gave here is just a set of high-level requirements that I just based on some requirements from an RTCA standard on the minimum operational performance standard for aircraft surveillance applications system. The SAP function shall receive the time of applicability, TOA, of the received traffic state data from the ADSB TISB receiver. Of course, these requirements are very short, pretty unambiguous. They use still some terminology like given over here, ADSB, which stands for Automatic Dependent Surveillance, but in the document itself there is a glossary explaining some of these terms. There's also graphs that actually explain some of these requirements in a little more detail as well. Okay, so if you look at the requirements capture output, of course we need the high-level requirements, derived requirements. It's one the output in the requirements document, and that's that. Now, so if you look at these requirements, I'm going back now to requirements in general. If you look at this block diagram, we have like S1 through Sn, which are the system requirements. Each of these system requirements, you're breaking them down in multiple high-level requirements. Then, of course, in the end, you're going to have a couple of these over there that are derived requirements. Then the high-level requirements are then turned into a set of low-level requirements. And again, there's a set of derived requirements you cannot directly trace back to in this case, a system requirement, in this case, a high-level requirement, but are really necessary for the software component to do its job. So that's what I'm saying here. So this back and forth. Okay, so in this case, there's I put the derived requirements here, and I put an extra definition from ARP 4754. Now, so this, what I call, so if you have a high-level requirement H1, I break it down in a set of requirements L1 to L2. I can now say that L1 through L2 whatever can be traced back to H1. At the same time, H1 can be traced back to L1, L2, etc., etc. Well, since H1 and H2 are here, can be traced back to the system requirements. So there's traceability, and traceability goes two ways. S1 is traceable to H1, H2. H1, H2 is traceable to this first system requirement. So we refer to this as traceability. High-level requirement is traceable to one or more low-level requirements. This is the parent and the child. But at the same time, it's bidirectional, so the low-level requirement is traceable to some high-level requirement. Traceability is an extremely important attribute when talking about verification. So if we talk about validation, verification, remember we've seen this before. In verification, we try that everything that we generate is correct as specified. So we say, okay, in validation, we say the the requirements are correct, result in a product that provide a system that performs the intended function. And in verification, we say that the product is actually implements whatever the requirements it should implement. Now, part of this is traceability. Just what I said. It tells you that all components at one stage of the life cycle have been addressed at the next level of the life cycle. So if one stage of the life cycle is coming up with system requirements that you want to, and the next stage is the software high-level requirements, you want to be able that we can trace every high-level requirement to system requirements, or otherwise identify it as a derived requirement. Okay. And the question that you want to do is, did I lose any functionality going to a low level of requirement? If there's a particular system requirement there and I can't find anything in my high-level requirements, that means that I lost functionality. It means there's no traceability to a high-level requirement. It means it may not be implemented. Okay. So there's downward and upward, bidirectional traceability. Traceability shouldn't be mixed up with compliance. Compliance means that two requirements at different levels, different stages of the life cycle, are in technical agreement. Okay. A lot of cases, traceability is, these two are mixed up. Okay. So if you look at the verifications of the requirements process output, you find compliance and traceability as explicit objectives as part of the verification process. So for example, these two, you have a high-level requirement here. It's textual, kind of pseudocode like textual, and then there's low-level requirement, which is pseudocode. You see, more or less, it's the same thing almost, but it's just a demonstration of these two. This one is clearly traceable to that one. This one is clearly traceable to that one. Parent, child. The only thing that you see is, if you look technically speaking, you see, okay, I'm implementing the same thing. However, here this low-level requirement added this little level arm, which we did not see in the high-level requirements. So somehow a person that took the high-level requirements document, used some additional information, or made a mistake and added this little level arm. Well, if you do that, these two requirements are traceable to each other, but there's no technical agreement. And of course, in your review, when you check it out, You want to find these kind of errors, find out why they're there, and check out if either the low-level requirement is incorrect or if the high-level requirement was incomplete. Okay, so traceability benefits. You really need it. It's often, its importance is often underestimated. You really need it to pass certification authority audits. It provides confidence that the regulations are indeed satisfied. It's very, you can easily see if I actually want to make a change or want to perform maintenance, I can actually see what impact it will have. Then it helps with project management. I can see, okay, are all my requirements traceable to some other requirements? Challenges is, of course, to do this proactively. Make sure that you do it and keep doing it, not that after the fact you're trying to perform traceability. You have to really do it while you're deriving. So in other words, related to that is, of course, to keep the trace data current and make sure that the traces are bidirectional. You go top down and bottom up. In other words, you're going to go from the system to the high level, but also from high level back to the system requirements. If you have many traces, in other words, traces that go from one spot, from multiple spots in the system requirements to multiple spots in the high-level requirement, that may be a symptom of a problem. Also, make sure that you know what's derived and what's not. So in case you think it's a derived requirement, but it's really already in some of the functionality that was defined in the system, for example. So again, related to that are the weak links, where you actually don't know exactly if it is derived or not, so if it should be traced to another requirement or not. Well, you see also, if you want to use implicit traceability, where you use naming conventions, this is also, challenging really, but you can do it. And of course, robustness testing traces, you need to make sure that you establish those as well. Again, all these things that I just talked about need to be documented. So traceability and compliance is a verification activity. So you need to make sure that you document that. Document if you find problems with traceability, problems with compliance, and make sure that you identify actions to fix it. So tools you can actually, there's a ton of tools that allow you to establish traceability. Even in things like MathWorks or Doors, you have a bunch of traceability options that you can do too. So, so you want to make use of tools. Traceability matrices. So an example for a traceability matrix would be here, where I have a particular requirement, and it's traceable to a high-level requirement, a low-level requirement, a piece of source code, a set of tests, and a compliance verification document. Yeah? So this matrix here is just a tool. Yeah? I can use this matrix. It's not the evidence itself. For the evidence, I really still need to go to this particular high-level requirement, but this is a tool so I can easily say, okay, let me look at this high-level requirement, now look at the system requirements, and make sure that indeed they are the same.